is one achievement of putting negative feedback. So negative feedback results in reduction of lower cutoff frequency and improvement of low frequency response of the amplifier. Two things you have to understand. So when you're applying a negative feedback, first thing, the lower cutoff frequency is reduced. It will be renamed as FLF. And FLF equal to FL by 1 plus A mid into beta, or FL by capital D. So reduction in the lower cutoff frequency will take place, and the low frequency response of amplifier is improved. So the amplifier will have a very good low frequency response. The amplifier will work even in the low frequency region. So if you have designed an amplifier, if you want an amplifier to work at 10 kilohertz, but an amplifier starts working only after 25 kilohertz, but it has to work at 10 kilohertz, means if you apply negative feedback, even the 10 kilohertz will be covered. So the amplifier will have a very good low frequency response. Okay, please understand that. So now, upper cutoff frequency. As I told you, bandwidth is made up of two frequencies, FL and FH. We have seen what will happen to FL. Can anybody guess what will happen to FH? FH will be somewhere here. So what will happen to FH? Can anybody guess after applying feedback? What will be the guess? We'll see if your guess is correct. The FL is moving towards the left. So how, in what direction FH should move? So that bandwidth is larger. Towards the same direction or in the opposite direction? Same direction or opposite direction? Same or opposite? FH should move in the opposite direction. Only then bandwidth will increase, right? So FH will become FHF. So we will mathematically find what is the expression for FHF. Okay. So that logically we have shown the direction and how that FHF value will be, but mathematically we'll prove that. So we'll again start from, see here we start from A low by A mid. Here I'm going to start from A high by A mid. And this is the frequency response of amplifier in the high frequency region. High frequency means where there are reducing portion of your graph. This portion we are not bothered because the gain is constant. I am more bothered about low frequency where the gain is increasing, and the high frequency where the gain is decreasing. At this portion, the gain is constant, so I am not going to be at all. Please understand that clearly. So A high by A mid equal to 1 by 1 plus J F by FH. FH is the upper cutoff frequency. See, some books, they refer it as FL, FH, higher cutoff frequency, lower cutoff frequency. Some books, they refer it as FU and FL. Some books refer it as F2 and F1. All are correct. So whatever is comfortable to you, please follow that. Okay, there is no difference in the way logic. The difference lies only in the variable name. Okay, so FH, FL is also correct. FU, FL is also correct. F2, F1 is also correct. If you like writing it as F upper, F lower, that is also correct. Okay. Cross multiply A high equal to A mid by 1 plus J into F by FH. So I have the gain of the amplifier in the high frequency region without feedback. So if I want to find the gain with feedback, I'll be using the formula AF equal to A by 1 plus A beta. So instead of A, I will be using A high. So A high by 1 plus beta into A high. And what is the value of A high? This one, substituted here. So see here, A mid by 1 plus J into F by FH divided by 1 plus beta into A mid by 1 plus J into F by FH. Same way, take LCM, cancel out the terms in the numerator and denominator, write the remaining terms. So A mid by 1 plus J F by FH plus A mid into beta. See, the steps are going to be exactly same. If you understand what we are doing for lower cutoff frequency stepwise, it is same. We do it for upper cutoff frequency. And how to remember this term? See, you remember for lower cutoff 1 by 1 minus J FL by F. Upper cutoff, it will be opposite. 1 by 1 minus plus J into FL by F will become F by FH. See, lower cutoff and upper cutoff frequency are completely in the opposite side, right? So if you use minus sign there, you use plus sign here. If you use FL by F, here I'll be using F by FH. See here, logically, you can remember all these expressions without by hearting. So remember one thing, lower cutoff frequency is 1 by 1 minus j FL by F. So high frequency will be 1 by 1 plus j